Hai semua, Assalamualaikum. Selamat datang ke channel Cikgu Rashidah. Assalamualaikum warahmatullahi wabarakatuh. Today I want to share with all of you how to solve the Newton's second law of motion. So, figure above shows a block of mass m1 6 kg on a horizontal surface with coefficient of kinetic friction K 0.22 is connected by a string through a pulley to another block of mass m2 3 kg. The system is released from rest. A. Draw the forces acting on the blocks when they are in motion. Second, calculate the acceleration of the blocks. And C. Calculate the tension of the string. So, the first step is we draw all forces acted to the body. So, for mass 1, there is a tension, normal force, and weight 1. And in this question, they give us mu k, so there is a frictional force opposite the motion. So the acceleration is to the right. The acceleration here is downwards. So for mass 2, there is a tension and weight 2. Okay, so we draw all forces acting on the blocks. And B, calculate the acceleration of the blocks. So from the diagram, we transfer all forces into the free body diagram. So for mass 1, there is normal force, tension to the right, weight 1 downwards, and frictional force to the left. For mass 2, the free body diagram, the tension is going up and weight 2 downwards. So the acceleration is to the right, and here the acceleration downwards. After we draw a free body diagram, we transfer the force into table. So we draw the table. For mass 1, forces, x component, y component, and we substitute and T, frictional force, and weight 1. So we put into this table. So N is 0 because the direction of normal force is upward. So N is positive. T to the right, T is positive, and Y component is 0. Frictional force to the left, so negative F, and Y component is 0. So weight 1 in y component but in negative direction. Okay, for mass 2, our table is for mass 2, force, x component, y component, and T and weight 2. So both are in y component. So T is positive and weight 2 is negative. So this is net force in component X, and this one is net force in component Y. So in the motion is in component X, so net force in component X is equals to M1A, and net force in component Y is equals to 0. For table 2, net force in component X equals to 0, and net force in component Y is equals to M2A. So after that, we calculate the summation force in component X. So summation force in component X is equals to M1A. So we substitute T plus negative F is equals to M1A. So T equals to M1. M1 is, the given M1 is 6 kilogram. So 6A plus mu N, because the frictional force is equals to mu times N. And what is N? So the net force in component Y is equals to 0. So N plus negative weight 1 is equals to 0. So N equals to M1G. So M1 6 times 9.81. So we get 58.86 Newton. And we substitute into this. So T is equals to 6A plus, given mu K is equals to 0.22. So we substitute 0.22 times 58.86 Newton. So we get T is equals to 6A plus 12.95. So this is equation 1. And we must calculate, we must determine the another equation for T. So we take from table 2, net force in component Y is equals to M2A. So T plus negative weight 2 is equals to M2 times negative A, because the A is downward. So T T equals to M2G minus M2A. So M2 is 3 times 9.81 minus 3A. So we get 29.43 minus 3A. So we have another equation. This is equation 2. So in this system, the tension are same. So equation 1, how do we solve it? Equation 1 is equals to equation 2. So 6A plus 12.95 equals to 29.43 minus 3A. So we rearrange 9A equals to 16.48. Therefore, A equals to 1.83 meter per second square. So this one, we get the answer for acceleration for A. Okay, we finish number A, B, and how to calculate the tension. So we can choose anyone, either equation 1 or equation 2. So I choose equation 1. So substitute A is equals to 1.83 meter per second squared into equation 1. So T equals to 6A plus 12.95. So 6 times 1.83 plus 12.95. So we get the answer is 23.87 Newton. So this is our answer for tension. Okay. That's all for today. Thank you for listening.